In this lesson, we're going to look at solving quadratics using the quadratic formula. So up to this point, we've just used rules that we know of, completing the square, perfect squares, factorizing, null factor law, things like that. Now we're going to introduce the quadratic formula or the quadratic equation. And this is really, really powerful. You can do a lot with it. It makes some of these steps much, much easier rather than going through those manual processes. So let's have a look. Firstly, let's have a look at a little sort of lesson starter. So I want you to complete the table. So we want to find the number of solutions for each equation. And we're given the equation. They've shown the example. We've got A, B, and C. So in this case, A is here, B is here, C is here. Pretty much the same as we've been talking about so far. So nothing different there. Then the next line here, they want you to calculate what is B squared minus 4AC. Then in this case, I want you to calculate, it gets a bit hectic, gets big real quick, minus b plus the square root, remember your bed mass. So if you do this in a calculator, make sure this is done first, then square root it, and then work from that point. Otherwise the calculator may mess up the ordering of this question. Then exactly the same, but instead of plus, you've got minus. And I want you to work out these solutions. So have a quick look at the first one. A is going to be 2, B is going to be 7, C is going to be 1. Now, b squared minus 4ac is going to be 7 squared, 7 sevens are 49, minus 4 times a, which is 2, so 8, times c, which is 1, so we got 8. So 49 minus 8, 41. Now we're doing minus b plus the square root of b squared minus 4ac over 2a. I can't do that in my head, and I don't have a calculator with me right now, so I'm sure you can work that one out. So from this table, see if you can work out a pattern. Is there a common theme at which a quadratic has two solutions? It has one solution and it has no solutions. So what do you notice about this table? What kind of things are following a pattern where we only have one, two, or no solutions? So in terms of this quadratic equation, the general formula for it can actually be found by completing the square for a general quadratic. So something like this, the ax squared plus bx plus c. So what they've done is they've started by dividing by a. And this process, again, this is just showing how it's created. You are definitely not going to need to be able to recreate this. You don't really need to understand where it comes from. This is really just some information in case you're really curious about how this equation comes about. But in reality, we really just use it all the time and we take it for granted. So this is the process. So they've divided by a, they're then factorizing out. So you can see we're using this difference of two squares thing. We've got our b on 2 squared, b on 2 squared. We're factorizing a little bit more. We get it to this point. So we get this expression minus this expression equals 0. Therefore, we can move this to the other side, which is this. And now what we're actually trying to do is we're trying to solve for x. We want x to be the expression that we're talking about. So that means we then take the square root to cancel it, and that's where the plus and minus comes from, remember? Because anytime we square root now, we technically have to plus and minus. And then we can move the b on 2a over to the other side because it's just an expression. And we get this, x, b on 2a minus b on 2a plus or minus b squared over 4ac. We can then just sort of condense that and go, well, we've got common factors, common denominators, so therefore the top line just becomes this, and it's all over 2a. So that's how the quadratic equation comes about. As I said, you don't need to be able to recreate it. If you can't really follow the steps, that's completely fine. There's a proof here of the same thing, but just sort of showing a little bit different, and it gives you a few more hints of like dividing by a, completing the square, factorizing, we get our expression. But what you need to know, what's really important, is that if this is your quadratic, and it is, this is the general form, the quadratic formula is in my post-it note over here, is this. And what it's telling you is it's telling you the x values. It's telling you the solutions, or the roots. Remember, we call them roots. So if you plug this in for any quadratic, you substitute your b's, your a, your c's, etc. Your solution will punch out, you will find the factors of an x. You can even try that. Look at a question that we've done last lesson. Plug in the quadratic equation, See if it gives you the same answer. And it should. I really hope it does. Otherwise, something's gone wrong. So let's look at a worked example. So we've got x squared minus 2x minus 6. Hopefully you can see a is 1, b negative 2, c negative 6. So if we look at our solution here, exactly as we said, a, b, c, we plug them in. So minus 2, 1, minus 6, 1. Crunch all that in the calculator, or if you want, you can sort of do it a step by step. You get this, 2 plus or minus root 28 over 2. That's nice. We can then condense that into 2 root 7. So if you remember the surd rules, whoops. If you remember your surd rules, we can condense that from root 28 to 2 root 7. And we can condense. Again, the problem with doing this in a calculator is a calculator is probably just going to give you an answer. So it won't give you root 7. It won't give you an exact value. It'll give you a number. So it'll give you a decimal place. And that's not really any good because when we want to solve them exactly. So in this case, we actually want to be able to condense all of this into, or by hand, by mathematical methods, rather than just crunch it in a calculator. Some of the better ones, your graphics calculators and things like that, can do this, and they can give you a certain answer, but most of the scientific ones we've got can't. So you follow that through, you get 1 plus or minus root 7. Just pause the video now and have a go at part B before I give you the answer. Again, we need to identify what are our A, B, and C. So A is 2, B is 3, C minus 6. So the minuses, the negatives or positives apply to those coefficients. Sub everything in. We got this minus 3 plus or minus root 57 on 4. That means we've got two options. We've either got x equals minus 3 plus root 57 on 4, or we've got minus 3 minus root 57 on 4. So we've got those two options, two solutions to the equation. Let me just rub that out real quick. Great. All right, let's do some practice. Using the quadratic formula, solve, see, notice it says exactly. So that means you can't just put it in a calculator and give me decimal numbers. I need the exact solution. And in this case, rearrange the following so they're written in the general form of a quadratic, ax squared plus bx plus c, then use the equation to solve it. So we need it, we can't use the quadratic formula for an expression like this because I don't know what a, b, and c is. So I have to expand, move everything over to the right side to get that general form. So let's look at, in this case, we're going to do, whoops, let me try and redo that a bit neater. Let's do column 1, column 3 for the first question. And then this looks like some good stuff, some rearranging. We're using the quadratic equation, so it's not too bad. Let's do, you know what? Let's do all of them. Why not? Quadratic equation, need lots of practice of it. We use it a lot. Let's do all of question 2. Solutions are on the next page. So here's some low-res solutions of the full step-by-step working process. And once you're done there, I will see you next lesson.